Hello, everyone. My name is Chase. I'm a product manager for AKS, focused primarily on networking. And my goals today are to explain networking best practices in AKS. Now, networking can be complex. It can be challenging, especially if that's not your background. And on top of that, Kubernetes itself can be complex and challenging. So what I'd like to do today is clarify that a little bit for you. And what I'm going to do is give you a framework to put networking into a Kubernetes-centric framework. And that should help equalize a little bit, give you a little bit more context and know how to put it into your clusters. So we break this down into, as I said, a Kubernetes-centric framework, starting with the control plane. Then we'll move on to node networking, into pod networking, and application networking. So you can think about your networking choices in all these categories. And for each of these categories, to help you decide a little bit more, we pose a question that you should be thinking about when making a decision for each of these categories. So for control plane networking, that question is, how do you want to access your API server? Keep that question in mind as we move forward, because this is what you're trying to answer with your control plane networking choice. So first of all, what is the AKS control plane? So the AKS control plane is a hosted control plane in a Microsoft managed environment. That means Microsoft owns it, manages, it's separated. You don't have to worry about it too much. And what it does is runs the API server, the controller manager, the scheduler, and other core components. And why it's important is because nodes and end users need to be able to access the API server. Nodes to get updates, configuration updates, anything like that, and end users to be able to access and control their clusters. So the first option is a public cluster. So the public cluster, the API server is accessible via a public IP address. Now, it doesn't mean it's wide open. You can restrict access to certain source IP ranges. And this does use connectivity tunnel for node and pod access. So as you can see, going from your Kubernetes node pool, it goes across the internet, it stays within Microsoft, but it does reach a public endpoint, and then to the AKS cluster API server. And again, it's a public IP. As opposed to this, you have what's called a private cluster. Now, private cluster uses Azure Private Link. The API server is accessible via an internal IP address. Azure Private DNS is used for the API server hostname, and this also does use connectivity tunnel for node and pod access. And you can see there's no more internet in between the Kubernetes node pool and the API server. However, this is a little bit more complex, though it is more secure. You have to use private link service. You have to set up private endpoints and manage access throughout. Now, as a part of this, you have what's called API server VNet integration. So we already said that the control plane is hosted by Microsoft, which means that it's in a Microsoft VNet. It's controlled on there. In this case, if you turn this on while it's in preview, API servers are provisioned into a delegated subnet from your VNet. Now, this still also may use connectivity tunnel for pod access and an overlay network or a BYO CNI cluster. But what this still does is keeps that traffic directly within your VNet. So it's much more secure. And on top of that, while going from a public or a private cluster to the opposite, you can do that. Typically, you're going to have cluster disruption. With API server VNet integration, you can remove or add public access at any time without cluster disruption. So there's a lot of benefits to going this direction. So what should you choose? Public cluster is the general recommendation. It's the most simple. It's easy to set up and you don't need to worry about it too much. Now, if you have security or compliance requirements, we recommend private cluster. API server VNet integration is going to be our standard recommendation to include in your clusters once it's generally available. And you'll still be able to set public cluster or private cluster, but it'll just be done in a much more secure way and easier managed. We're moving on to node networking now. And the question here, just like with control plane networking, is how do you want your cluster to access the internet? This is the question we're trying to answer here. So what is node networking? Our definition is networking for your AKS nodes to access each other, the API server, or the internet. So there's two parts to this one, and we're going to make our decision really quickly here for the VNet selection. There's a managed offering, which means Microsoft or AKS owns and manages that selection and manages the subnet delegation and all that stuff. Or you can bring your own VNet, which means you own that process. Now, the really main part that we're asking here is different cluster outbound types are available depending on your networking needs. So the first one is the load balancer. And this is the default configuration. It's just an Azure standard load balancer, and it uses the load balancer rules, and it has fixed NAT ports that are assigned per node on node creation. And you can see this traffic flow. The Kubernetes node pool goes to the Azure load balancer out through the egress IP, and then any internal traffic or incoming traffic goes back to that same load balancer and is load balanced across your node pool. You have NAT Gateway, which is a managed option in the managed VNet, or you can use this one in BYO VNet, as opposed to the load balancer option. That one's entirely only managed by AKS. What this does is it has better snap port handling than the load balancer. So if you have a large amount of outbound connections that could cause snap port exhaustion for the load balancer, then you want to take a look at NAT Gateway. Now, this isn't zone redundant yet without specific configuration. So there's a little bit more management that you can do to do that. But in the future, this will be zone redundant. Which is a good feature to have. And for this traffic flow, you can see the same thing. You have your traffic going out through the NAT gateway, out to the egress IP, and then for the incoming traffic, that still goes to the load balancer and to your Kubernetes node pool. Our third option here is user-defined routing. This is a little bit more customized and managed by you. If you want to have explicit control over your network with your bring your own VNet, this is only bring your own VNet. You must have a default route to an Azure firewall, a vWAN, or some kind of NVA. And this doesn't typically support external load balancer services directly, but that's you can see the traffic flow here. And your traffic starts with going out through your route table, your UDR, to your firewall or appliance, and then out through the egress IP. And then incoming traffic will come back in through there. So your firewall can inspect the traffic. It'll be network address translated over to your service IP, and then over to an internal load balancer and load balanced across your network, across your node pool. So which should you choose? Load balancers are general recommendation. Again, we aim for simplicity. We want to be able to manage this for you as much as possible so you can focus on running your workloads. However, if you have a high volume of outbound connection requirements, depending on your workload, NAT Gateway is the better option. You won't have to worry about that at all. UDR is if you have custom needs. Let's say you do want to run everything through a firewall or an NVA or something like that, then you can set up your route and have your egress managed that way. All right, moving quickly on to pod networking. And our question here is, do you need direct pod IP access? There's a little bit more to this one, but that's still the core question that you're trying to answer. So what is pod networking? It controls how your pods have IP addresses assigned. It defines how pods communicate to each other, cluster nodes and destinations outside the cluster. And Kubernetes provides pod networking via CNI plugin. So another little bit of clarification, what's a CNI plugin? A CNI plugin is a container networking interface plugin, and it configures pod networking. And for the purposes of choosing a CNI, this has two parts. The first is IP address management, or IPAM, and the second is routing and transport, or the data plane. So we're going to start with IP address management. This is where most people think of CNIs. And so for our purposes, we really have Azure CNI as our option. We have different options within Azure CNI to get you what you need. So the first option is the overlay networking model. And an overlay networking model means that pod IPs come from an overlay range that are not a part of your VNet. And our option for this is Azure CNI Overlay. So this is our most scalable option, and it gets up to 5,000 nodes and up to 250,000 pods. And with Azure CNI Overlay, you can reuse that same pod space, which is a private space, across all of your clusters without conflict. Now, there's a little asterisk there in case you're doing things like VNet peering or express route or something like that. Then that direct connection could cause conflicts with the private IP space if you're using it. As you can see here, your pod CIDR is coming from 10.10.1, where your nodes have a 192.168. Both of these are private spaces. We're just using this as an example. But this is completely separate. You can reuse the same space across all of your clusters. Traffic leaving your pod clusters are going to be snatted to your node IP. And that's how we can reuse that across all the different clusters. Now, Azure CNI Overlay also has dual stack compatibility, which is IPv6 or IPv4. And pods cannot be accessed directly from outside the cluster. So that's the caveat here. If you need direct pod IP access, Azure CNI Overlay might not work for you. Now there's the flat networking model. And a flat networking model means that nodes and pod IPs come from the VNet space. This is the option where pods can be accessed directly from outside the cluster because pods are getting a VNet IP. We have a few different options, and it's still Azure CNI, but this is pod or node subnet. So the IPAM options allow for efficiency or scale or even simplicity. So pod subnet dynamic IP allocation is for efficiency. If you have some IP constraints and you want it to be the most efficient option, then dynamic IP allocation for pod subnet is going to be your option. And for pod subnet, you have to have some subnet management. There comes with a little bit of complexity because you have to delegate a subnet for your nodes and delegate a subnet for your pods and make sure that you have that correctly scoped to handle the scale that you need. The same for pod subnet static block allocation. This is for scale. We recommend this mainly if you're going to do something really high scale. With dynamic IP allocation and node subnet for that matter, you run into a limitation of 64,000 nodes, 64,000 IPs for your nodes and pods. So you're going to hit a limitation depending on your scale pretty quickly. But for static block allocation, you can actually get up to 1 million pod IPs. However, it is not as efficient. So those IPs are not going to be used efficiently. And you could, if you don't plan correctly, run out of scale pretty quickly or run out of IPs pretty quickly. Node subnet still has the 64,000 IP limit, but it is the simplest option. You don't have to worry about delegating any subnets. You just turn it on. AKS manages that across, and you still get direct pod IP access from outside the cluster. All right. Now, this is the second part of an Azure CNI, which is the data plane. And we have two options. We have Azure CNI powered by Cilium, which is an ePBF data plane. We're not going to dive into ePBF today because that's a little too deep here, but at a high level, it makes things more efficient, it makes things more scalable, and it has built-in network policy management. This also opens up extra capabilities for enhanced network policies like FQDN filtering or even L7 coming soon for advanced, and this is within advanced container networking services. So ePBF data plane is the recommended option for most customers. Now, there's also the Azure, quote unquote, Azure data plane, which uses IP tables. IP tables are in a strange place. They might be going away, all of those things. So we do recommend the ePBF data plane. It's where all of our investments are going. It's where the most performant and scalable options are right now. So with the IP tables data plane, you do have to install a network policy manager if you want. We have Calico, and we also have Azure Network Policy Manager, which is NPM. This is not recommended. NPM has some pretty severe scale limitations, but we do list it here because it is one of our options. So Calico, or ideally Cilium ePBF data plane is our better option. Both of these options support all of the Kubernetes spec network policies, but the Calico and NPM do not support any of the advanced features or advanced policies. And both of these options are supported by all Azure CNI IPM options. So choosing Cilium is not an either or for your IPM option. Now, we do have bring your own CNI, which means you can bring a CNI to AKS if it's supported from that CNI. There's no managed CNI plugin installed, and you can use any option for AKS, but CNI related issues that come up are not going to be supported by Microsoft. We can't support if something happens to your CNI. That means we won't be able to create a ticket or do anything like that. And so we do recommend one of our supported options and having us manage it. So which do you choose? Azure CNI Overlay with Cilium is our general recommendation. It's the most scalable, the most simple. You don't have to worry about anything, and it's very efficient and on par with performance with our other options. So performance-wise, all of these are very similar, and this is our best scalable option, especially since you can reuse this same space across your clusters. Now, Azure CNI Pod Subnet, if you need direct pod IP access and you have efficiency or scale requirements, that's how you choose Pod Subnet, and then you can choose either the dynamic IP allocation or you can choose the static block allocation. Azure CNI Node Subnet, which means that all of them are coming from the same VNet, but you don't have delegated subnets. This is your choice if you need direct pod IP access, and you can deal with simplicity. They're still going to have some scale limitations at 64,000 IPs for nodes and pods, but you don't have to worry about any subnet delegation or anything like that. Very simple. All right, our final topic is short and sweet. How do you want to access your applications? This is the application networking, and your question is, how do you want to access your applications? So what is application networking? This is how applications running in your Kubernetes pods are exposed to clients from outside the cluster. All right, the first option is a load balancer service, and this is just layer 4 load balancing. This utilizes a Kubernetes load balancer service to directly expose an application on a public or private IP. Now, this supports multiple ports and any TCP or UDP traffic. This requires at least one unique IP port pair per application. So it takes some management, takes some consideration, but if you're only working with TCP or UDP traffic, something like that, then you're going, or similar traffic to like that, you're going to want to use just a layer 4 load balancer. The other option are ingress controllers, and this is for layer 7 load balancing. So this exposes an application behind a layer 7 reverse proxy. This is usable only for HTTP-like traffic, so HTTP, HTTPS, gRPC, other things like that. Now you can share a single public IP and ports for all ingress definitions on the same ingress controller, which is helpful and simple. We have a few managed ingress options. The first is Nginx. So this is an Nginx ingress controller through application routing add-on. And this is a great simple option. There's not a ton of capabilities. And also it's, I think it's going to be retired. The project is kind of going away and those things. So we still support it. But for the future, we recommend something like Azure Application Gateway for containers. It's going to bring a bunch of new features and capabilities, things like gateway API support, traffic shaping, and all of the advanced capabilities that you might like. We also have Istio Ingress Gateway, which is compatible with the Istio add-on. And similar to Azure Application Gateway, there's more control, there's more advanced features, and things like that. So which did you choose? Again, a simple choice. If you have HTTP-like traffic, then you're going to want to use an ingress controller. And you can choose which one of those managed offerings to do, or something self-managed if you like. But one of our recommended options are our managed offerings, then you're going to want to go with an ingress controller option. Now, if you don't have HTTP-like traffic, then you're going to want to go with a load balancer service, TCP, UDP, SMTP, those types of things. Nice, simple, easy, and yeah, that's how it'll work. So with that, that's how you think about networking in AKS. Those are your options. I hope this really helped you out. If you have any questions, feel free to drop them in comments or reach out to AKS Microsoft. Thank you.